Hello friends, welcome to another video. In this video we will discuss why 1090 is not defined. So it is a very important concept. Okay, let's us understand this very carefully. So before that, let us consider a right angle triangle, that is this right angle triangle A B C. Okay, now this is base, the angle theta, this is angle theta, for which we will find tan theta, and this is 90-degree angle. Okay, so the side opposite to the 90-degree angle is hypotenuse and the side opposite to the theta is perpendicular. Okay, and this is the base. Now we all know that tan theta equal to perpendicular by base. Tan theta is another formula, that is sin theta by cos theta. It is also very important formula and it is the use of proof. Okay, it is there in the proof. We can simply prove this by sin theta. Okay, now we all know that sin 90 equal to 1. Okay, we all know that sin 90 equal to 1, and for cos theta the cos 90 equal to 0. Now for tan theta we all know that means tan 90, if we are finding tan 90. Okay, so tan 90 it is sin 90 by cos 90. Okay, the same theta we will find for every function, every trigonometric ratio will find the same theta angle. Okay, now we can find that sin 90 is 1 and cos 90 is 0. So when 0 is in the denominator, this value will be not defined. Okay, when 0 is in the denominator, this value will be not defined. So here is the simple proof we got. Okay, by using the ratios, the derived ratios of sin theta and cos theta. Okay, this is very important proof, but let us understand the concept behind this. Now consider this triangle. It has perpendicular, it has hypotenuse, it has base. Okay, and we will find tan theta. Okay, we will find tan theta. Okay, tan theta. For this theta, consider this theta, and the triangle is ABC. Consider only, focus on this theta. Now let us, here theta is less than 90 degree, theta is less than 90 degree in this case. Now I am increasing theta, okay, theta I am increasing and it approaches to 90 degree, I am just increasing. You can see on increasing theta, the meeting point of hypotenuse and base is just increasing. Okay, see, when theta was this, the meeting point of perpendicular and hypotenuse was this, and perpendicular of this height. Okay, let x centimeter. Okay, but when we are increasing theta, the meeting point was adjusted. The meeting point of hypotenuse and perpendicular is just shifted upwards. So here x increases, means the height of perpendicular increases, because the meeting point is shifted upwards on increasing theta. Again I consider this case, I again increased theta more and more. Again the meeting point shifted upwards, and again the x increases, means the height of the perpendicular increases. Now it is just near about 90 degree. It is just near about 90 degree. The theta is just near about 90 degree. So we can assume that I have not much space, but we can assume that perpendicular and hypotenuse are meeting at some point, but these are plotted with dotted lines, that they are meeting at some point means very much distance. They are meeting at much distance, very much distance, and we are just assuming. Okay, so here also meeting point is shifted much distance away, so that's why I plotted it with dotted lines. You will better understand by this example. Here, if theta is exactly 90 degree, then you can't say that when they will meet. You can't even determine that when perpendicular and hypotenuse will meet, because it is assumed, okay, it is assumed that they will meet at infinity. Okay, it is assumed that they will meet at infinity when theta is exactly 90. Okay, you can see that hypotenuse and perpendicular are not meeting at much distance, but they are assumed to be meeting at infinity. Okay, because here perpendicular is very much long. Okay, because theta increases, so their meeting point is shifted to infinity. It is assumed like that. Okay, their meeting point is shifted to infinity. So here theta is 90 degree, so at this case they are meeting at infinity, because they are almost parallel, you can see. So parallel lines meet at infinity, we all know that. Now the concept here is, if they meet at infinity, so we can see that perpendicular means the length of perpendicular is also infinity. Length of perpendicular is also infinity. So we can see that P by B, that is infinity by base, and base is also getting shorter and shorter. Okay, P by B, that is infinity, we can assume that infinity by base. So it is always an infinity or not defined. It cannot be determined. So this is the conceptual proof. Okay, this is the conceptual proof of this chapter. I mean, sorry, this is the conceptual proof of this topic. Okay, I hope you got it. If seriously you got help from this video, anyhow, please share it to your friends, and also show some love by liking on the button. Okay, thank you. Let's meet on next video with a very much interesting topic. Okay, bye bye, take care.